Alright, hello, welcome back. Today we're going to explore what is a sequence and what is a series. You probably heard about this when you're in Algebra 2. Well, let's get right to it. Sequence. A sequence is a particular set of numbers that have a particular pattern, and a sequence will be, for example, in this case, an easier way, actually it can be any number, but the key here is to find an easier way to predict these numbers. Right now it's simple. It's just adding by ones, for example. You can see the difference is 1 for all of them. Alright. Now, for a sequence that have major implications, for example, we can use this to predict models in the future. That is why it's very important to understand this. And in almost all classes that you might have been, you're just told to memorize the following formula. Where does it actually come from? It might make intuitive sense at first, but if it doesn't, let's clear up some doubts. Alright, so we're going to call this term, for example, first term, second term, third term, fourth term, etc. And each term will be considered with a variable n. For example, n could be 1 as in first term, and so on. So, let's actually derive the following using common sense. So, un will indicate the actual value. For example, what is the third term? U third. Alright? So, here we can write the following sequence like this. 1, right? Now the difference is 1, right? So I can write also 1 plus 1, because 1 plus 1 is all of 2. Now let's go to the third term. 1 plus 1 plus 1. That's the third term. 1 plus 1 plus 1 is 2. 3 actually. Now do you see how these terms, the first terms, are always the same? Well, that's why we call this the first term, U1. U1 represents the first term. In an arithmetic sequence, the first term is very important. So, now how can we rewrite this in a general sense? Because we don't want to write this every time. Okay, so we see that the first term always takes an importance. We write, in this case, 1 or U1. And then we add it plus the difference. We've seen the difference is 1. In this case, the difference is represented with D. Common difference, might say, and so we represent it with 1. Now, using n, this is the first term and this is the second term. Now, we see how there's two of them, two ones, 3 ones, and 1 1 here. Now, the key is that although this is the second term, third term, there's only 1 1 here and 2 1s here. In other words, whatever the term is, in this case third, we're going to have 1 less amount of 1s. What do I mean with this? For example, if I expand this, four plus 1, 5. This will predict our fifth term. How many 1s do we have? 1, 2, 3, 4. Exactly. 4 1s. In other words, n minus 1. For example, here, if we plug in 5, 5 minus 1 will be 4. That is why common difference 3, n minus 1 will always equal our number, the number that we want. This is where the arithmetic sequence formula actually comes from. Thank you. Alright, we just finished proving where the arithmetic sequence comes from. Now, a maybe even more important question is, what happens if we have the same thing? Let's say 1, 2, 3, and so on. Same thing as here. But what if we add all these terms? Well, the first couple of terms is easy to add. You might add 1 plus 2, 3 plus 3, 6, plus 4, 10, plus 5, 15, and so on and so forth. At first it's easy, but what if I tell you at the first 100 terms, or the first 1,000 terms, what do? Well, you're not going to spend 1 hour on it. So, how do we do this? How do we take advantage of the very fact that they have common differences? Well, again, many teachers tell you to memorize the following formula. S, that means sum, we're going to add a certain amount of terms, equals n u1 plus un divided by 2. In this case, n is the amount of terms, first term, last term, divided by 2. Now, people just plug and chug, and they really have no idea what they're doing, and hopefully I can clear that up. Now, let's see. We have 1, 2, 3, 4. Same arithmetic sequence. Now, if we add the first term, 1 plus 2, 3, plus 3, 6, the important thing is that actually the thing that is actually bothering us is that when you add them, you get a different value. For example, 1 plus 2 is 3, 2 plus 3 is 5. We can't take advantage of something, but there's something perhaps that you've learned in elementary school, and it's called multiplication. When you multiply, it's like an accumulation of numbers. For example, if I tell you 5 times 2, it's the same thing as saying we have 5 2's or 2 5's that's being added. In other words, it's a simplification of an addition. So let's take advantage of this. Let's use all numbers 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, now what happens if we actually add the first term and the last term? 1 plus 10, 11. How about the second term and the second to last term? 2 plus 9, 11. Oh, okay, I'm getting the same number. Let's try that one more time to make sure it's not a coincidence. 3 plus 8, 11. Alright, same number again. What's going on? Alright, something very important that we see here is that this column, the numbers 1, 2, 3, is going up. In other words, that because these numbers are going up and these numbers are going down, when this one goes up 1, this number 10 goes down 1. In other words, that 11 summation will always stay constant. Now, alright, cool fact. Now what are we going to do with it? Well, we can actually take advantage of this very fact. Well, what happens if I actually list all of them? Plus 3, 4, plus, let's say, 7, and so on and so forth, until we reach our last term, or our last group. 5 plus 6 equals 11. Now, you see how we have all the numbers being added just in a different order? Well, if you just add them, you get 11s. How many 11s do we have? 1, 2, 3, 4, 5. 5 11s. That's like 5 times 11. This actually gives us our addition, which is 55. But sometimes, like I said, the summation is quite long. Well, how do we use this actual pattern that we've just discovered right here to make an actual formula, to come up with this formula? Well, perhaps it's slapping you in the face right there. You have U1, first term, last term of the sequence, in this case 10 terms, right? So we write 1 plus 10, this will give us 11, right? And how many 11s do we have? 5. Well, how many terms do we have? 10. 10 divided by 2 will give us 5. In other words, now if we represent all these numbers with an actual general term, 10 as in n, because we have 10 numbers, well, 2 just stays there because we're grouping them in pairs. When you get something in pairs, you divide by 2, because each pair has 2 terms. And 1 is just U1 plus UN. This actually gives us the summation of any arithmetic sequence. Now we can predict, let's say, the first 100 terms. We just plug it into this formula. But the very important thing is that many people ignore where this formula actually comes from. And hopefully you've actually discovered this in this video. Thank you.